Hello Middle 2, today we're starting Unit 1, Lesson 1. Let's get started. Unit 1, Lesson 1, Attempts of Element Classification. What are the most important attempts to classify elements? Many attempts are made by scientists for classification of elements according to their properties, in order to facilitate their study and find a relationship between elements. The most important attempts are Mendeleev's periodic table and Moseley's periodic table and the modern periodic table. First, Mendeleev's periodic table. It is the first real periodic table for classifying elements at the time. Only 67 elements were known. The Russian scientist Mendeleev explained his periodic table in his book Principles of Chemistry in 1871. How did Mendeleev classify elements? First, he prepared 67 cards. Each card represents an element. Second, he recorded in each card the symbol of one element, atomic weight of this element, and important properties of this element, like boiling point, melting point, and density, and formula of oxide. Third, he arranged elements of similar properties in vertical columns, which were known later as groups. Fourth, he classified elements of each main group into two subgroups, A and B, due to the difference between their properties. He discovered that the elements are arranged in an ascending order according to their atomic weights when moving from left side of the table to the right side in horizontal rows, which were known later as periods. The properties of elements were repeated periodically by the beginning of each new period. Advantages of Mendeleev's periodic table. 1. He predicted the discovery of new elements and determined the values of their atomic weight. Therefore, he left gaps, empty cells, in his table. 2. He corrected the atomic weight of some elements which were estimated wrongly. Disadvantages of Mendeleev's periodic table. 1. He had to make a disturbance in the ascending order of atomic weights of some elements to put them in groups that suit their properties. 2. He would have to deal with the isotopes of one element which were discovered later as different elements, due to the difference in their atomic weights. Mendeleev had to put more than one element in one cell, as iron, cobalt, and nickel, due to similarity in their properties. Moseley's periodic table. In 1913, the New Zealand scientist Rutherford discovered that the nucleus of the atom contains positive charged protons. In the same year, the British scientist Moseley named the term atomic number of an element on the number of positive protons in the nucleus of its atom. Discovered after studying X-rays properties that the periodicity of an element's properties is related to their atomic number and not their atomic weight, as Mendeleev believed. The most important modifications of Moseley's and Mendeleev's periodic table. 1. He arranged elements in an ascending order according to their atomic number, where the atomic number of each element increases by 1 from the preceding element in the same period. 2. He added to the table the zero group, which include the inert noble gases, the other elements that were discovered after preparation of Mendeleev's for his periodic table. 3. He specified a place below the periodic table for lanthanides and actinides. The modern periodic table. The recent studies led to the identification of the acute compactation of the atom, where the Danish scientist Bohr discovered the main energy levels of an atom as shown in the following figure, and their number reaches 7 in the heaviest known atoms till now. Scientists discovered that each main energy level consists of a defined number of other levels known as energy sublevels. Accordingly, the elements were classified in the new periodic table, known as the modern periodic table, in which the elements are classified in an ascending order, according to their atomic number, the way of filling their energy sublevels with electrons. The scientific principle of elements classification in Mendeleev's periodic table, Moseley's periodic table, and the modern periodic table. Elements are classified in an ascending order according to their atomic weight, their atomic number, and the way of filling their energy sublevels with electrons. This is the modern periodic table and its blocks. Description of the modern periodic table. The modern periodic table shown in the previous page consists of 7 horizontal periods where each period starts by filling a new energy level, and 18 vertical groups where each group has a traditional number and a modern number. The modern periodic table is classified into 4 main blocks: 1. S block, 2. P block, 3. D block, 4. F block. First, S block. It is located on the left side of the periodic table. It consists of 2 groups. The 2 groups of the S block take the letter A. It includes 2 groups, 1A and 2A. Second, P block. It is located on the right side of the periodic table. It consists of 6 groups. All groups of P block take the letter A, except 0 group, 18, which is noble gases. It starts with a group 3A, 13, and ends with a 0 group, 18. These are the S block and the P block. Third, the D block. It is located in the middle of the periodic table. It separates between the S block elements left side from the periodic table and the P block elements right side from the periodic table. It consists of 10 groups. All groups of the D block take the letter P, except group 8, which contains 3 vertical columns. It starts to appear from the period 4. It starts with the group 3B, 3, and ends with the group 2B, 12. The elements of the D block are known as the transition elements. Here is the D block. F block. It is located below the periodic table. It consists of 2 horizontal rows, which are lanthanides and actinides. How to determine the location of elements of groups A in the periodic table by knowing their atomic numbers. Write the electronic configuration of the atom of the element, and from this determine 1. The number of energy levels occupied by electrons. 2. The number of electrons at the outermost energy level indicates the period number of element and the group number of the element according to the traditional number. The following table shows examples on determination of the location of some elements of groups A in the periodic table. In the modern periodic table, in the same group, the atomic number of elements increased from the element preceding by 8, except helium element Li3, and that its atomic number increases than hydrogen H1 by 2. And in the same period, the atomic number of element increases from the element preceding it by 1. Don't forget to like, subscribe, and share this video with your friends. Thanks for watching. See you next lesson, Middle 2. Goodbye.